Welcome. This is a solar-powered media, designing for a more energy-positive internet. We're Benedetta Piantella, Tega Brain, Alex Nathanson, Keita Ohshiro from the Department of Technology, Culture, and Society at NYU Tandon School of Engineering. How would your relationship to the internet change if it were only powered by the sun? Have you ever thought about the carbon footprint of your online decisions? User experience designers, software engineers, and computer scientists alike are rarely tasked with thinking about the environmental impact and resource consumption of their design decisions, both when creating online platforms as well as when publishing online multimedia content. Furthermore, free or low-cost web hosting services encourage designers and users alike to overlook the substantial energy footprint of their online behaviors and interactions. To more deeply investigate the power consumption of our online actions and compare different design elements and choices, we created the Solar-Powered Media Project, a system designed to experiment with the intrinsic qualities of renewable energy sources in order to create more resource-efficient content and foster more energy-positive behaviors. To understand the environmental impact and energy expenditures of different server processes and front-end design decisions, we built a small solar-powered website and server using widely accessible off-shelf components. We explored using a combination of single-board computers and voltage current sensors to measure the energetic cost of actions, such as uploading a small image versus a large image, in an attempt to visualize the invisible and spark a conversation around energy-positive design guidelines. We were deeply inspired by the work of Joanna Moll on the energy consumption of common actions like purchasing Jeff Bezos' book on Amazon, as well as Mike Berners-Lee's research on the carbon footprint of everyday technologies such as email. We were also really inspired by Low Tech Magazine's solar-powered website, which employed interesting visual techniques to lower the size of its web content. Our own system is comprised of two main hardware components, a 50-watt photovoltaic panel and a ruggedized weatherproof solar server box, which contains all the hardware needed to power the solar server and its website. Both the parts list as well as code repository are available online for others to replicate and continue to experiment with. The data collected by the system includes things such as the PV voltage, which is the energy captured through the sun, battery charge, and server activity. Our front end explored the possibility of energy responsive design by allowing the stored energy in the battery to dictate the style of the website. If the battery is too low, the website might actually be unavailable until a sunnier day. We hope that together we can critically look at our digital lives and try to collectively reimagine what the new internet infrastructure could be and explore the opportunities and potential for a more naturally intelligent network. What services could actually be intermittent, just like the solar-powered media server? We recently launched Solar Protocol, a network of solar-powered servers distributed across the globe that route traffic to whichever server is at the moment enjoying the most sun. Thank you so much, and please get in touch with us.